Welcome to this amazing channel where we help students to excel in various examinations that they take. Of course, just like we have it there, we have a Discord channel, a Discord community for IGCSE and A levels. If you're interested to be part of this community, you can simply join through the link as shown on this slide. Okay, so we also have opportunity for personal tutoring. So if you're interested in having a one-on-one guidance on certain areas you do not understand, whether it's the GCSEs, the IGCSEs, or the A-level chemistry, you can also message the sales team, just like we have on this slide, and we'll be ready to assist you in whatever areas that needs our attention. I also have a lot of experience teaching the subject. We're able to attain excellent grades from A star to B in several years. So the resources, the explanations, the videos are very resourceful and very useful for anyone who really wants to get the best grade in IGCSE Chemistry. We also have some resources that we make available for fellow teachers, fellow instructors in the Cambridge IGCSE. So if you need the slides I use, if you need the worksheets, differentiated worksheets, and many other resources that might help you deliver the curriculum well. We also have that as a chemistry combo plan. We message the sales team as well, and then we make them available at a little cost. All right, so this video will just solve some questions that we have just to refresh, also help those who need guidance on how to give answers to these questions. So the first question here is on the state of matter, and then we have a table where you are asked to complete the table. So if you remember, this is one of the introductory parts of introductory part of chemistry where we look at the state of matter. So in terms of separation, in terms of the particle separation, you see that the solids are always closely packed. And because they are closely packed, what happens is that they vibrate about a fixed position. And then for the arrangement, you see that it's a lattice structure. What we mean by lattice is there is this regular arrangement or regular pattern of arrangement that gives it this well-arranged form. Also for the liquid, they are equally closely packed, but not as closely as packed, not closely packed like the solids. They have an irregular arrangement, or we could say they have a random arrangement. And therefore, in terms of movement, they simply slide over each other. And then for the gas, it's time that the gas particles are far apart. The arrangement is equally irregular and they move very fast or randomly in terms of movement. So this is all you just need to use to fill up the table. So just go back there and fill up what we have here. So for particle arrangement, we can simply fill it up here by saying it's regular. Right, and then for the particle motion, just like you have it on the slide I just showed, so you can say vibrate about a fixed position. So the particles in the solid are always vibrating about a fixed position. And then for the liquid, it's still touching, though not very close like the solid. And then the particle arrangement, you could just create a regular here, or you could have a random arrangement. Then for the motion, you could use the slide against each other. So slide against each other. Or you could say it's random. Say it's random. And then for the gas, of course, the particle separation is apart. So that is how to give a response to that particular question. So just like what I showed you on the the slide there. Now, we also have substances can undergo physical change. And you know what a physical change is? Physical change is a change that is reversible and there is no formation of new substances. This is quite easy. So when you're moving from solid to liquid, of course, you know that is melting. So that's melting. You're moving from gas to liquid, that is, you call that condensation. And then from solid to aqueous. So you're moving from the solid to aqueous. So that is simply dissolving. You're dissolving. That is when you see you're moving from the solid to the aqueous state. You're dissolving the solid. All right, so those are the answers to that question. So move to the next one. It is gases diffuse. Describe in terms of particles why gases diffuse. Now, remember, when we looked at the previous question, we saw the particle separation talks about that the particles of a gas are apart, right? And then we looked at the movement of the particles to be random, okay? So for this, in terms of particles, why gases diffuse? So gases diffuse because the particles are far apart, okay? So the particles are far apart, or you could say the particles can move freely. So because the particles can move freely, they would diffuse. So the response here is to simply say that the particles are far apart. Easy movement. When the particles are far apart, then they can move more freely. Now, states what determines the relative rate of diffusion of gases at constant temperature. So also back to the syllabus, you see what that diffusion is dependent on the relative molecular mass, okay, of the gas. So if you look at this, you see that lighter gas particles are able to move faster and cover greater distances than heavier ones. And how do you determine what gas is heavier than the other? By calculating the relative molecular mass. So the higher the relative molecular mass, the slower the gas will diffuse, and the smaller the relative molecular mass, the faster the gas will diffuse. So the answer here is simply relative molecular mass. Since it's at constant temperature, you were told it's at constant temperature. So that is the answer to that. All right, so we go to the next one here. It says gaseous oxides of nitrogen are atmospheric pollutants. One adverse effect of oxides of nitrogen is the formation of acid rain. The two other adverse effects of oxides of nitrogen. Now, this is under chemistry of the environment. So I'm going to share the slide I have here under chemistry of the environment. You can see oxides of nitrogen. These are from car engines. So when you have nitrogen in the air, reacts with the oxygen in the air at very high temperatures. That is how you form the oxides of nitrogen. Okay, so one of the adverse effects of the oxides of nitrogen is just like we have it here. We have photochemical smog. So you could see this here that one of the effects is photochemical smog. Acid rain has been mentioned. So one additional negative effect is the concept of respiratory problems. So there is the issue of respiratory problems. So we can add as photochemical smog as one of the adverse effects. And then the second one is respiratory problems, or you could say breathing problems. These are the issues with oxides of nitrogen. This is under chemistry of the environment, like we already said. Okay, so let's move to the next question. It says in a catalytic converter, oxides of nitrogen are removed by reaction with the toxic gaseous product of the incomplete combustion of hydrocarbon fuels. Now, two non-toxic gases are formed in this reaction. Now, name the toxic gaseous product of the incomplete combustion of hydrocarbon fuels. Now, remember, for example, if you have methane as an example of an hydrocarbon, and then you burn it in completely, you're going to have carbon monoxide and water, right? Of course, this equation needs to be balanced. So this is the toxic gas that is produced. So when a hydrocarbon incompletely burns, is going to produce carbon monoxide. So our answer here is going to be carbon monoxide. So I'll just write carbon monoxide here. Now, the next one says, name the two non-toxic gases formed in the catalytic converter. Now, we'll check the slide again. There's an equation of how the catalytic converter works under chemistry of the environment. Okay, and this is what we have here. So you could see that the catalytic converter introduces the carbon monoxide. And then look at the product. The product is carbon dioxide and nitrogen gas. So these are the two the two gases that are formed that are non-toxic. So this is the response or the answer to that question. So we just go there and fill carbon dioxide and nitrogen. So right, we have carbon dioxide, and then we have the second non-toxic gas, which is nitrogen. That is how to give answer to that. You can see these questions are quite easy. All right, so we move to the next one.
In today's world, science isn't just about passing exams. It's about understanding how the world truly works. At Ajiro Tech Tutoring, we help students master the sciences, physics, chemistry, and biology across all major exam boards, AQA, EdExcel, and Cambridge International. With our team of qualified tutors, every session is designed around you, your pace, your goals, your success. We don't just teach, we build confidence, critical thinking, and curiosity. And now, we're proud to say we are officially registered right here in England, in the UK, delivering trusted, high quality online tutoring that meets British educational standard. Whether you're preparing for GCSE, IGCSE, or A levels, Agile Tech gives you the tools to achieve your best result from the comfort of your home. Because with the right guidance, science becomes simple, success becomes natural, and learning becomes limitless. Begin your journey today at agiletech.com or message our sales team info@agiletech.com or agiletech@gmail.com. Agile Tech Tutoring, where understanding leads to excellence.
All right, so this takes us to extraction. So we should be familiar with the extraction of iron and also the extraction of aluminium. Now, iron is extracted from iron ore in a blast furnace, obviously. The iron compound in the main ore used in the blast furnace is iron 3 oxide. Okay, so states the name of the main iron ore used in the blast furnace. Okay, so this is straightforward. You know that the main ore is referred to as hematite. Hematite, right? And that's the iron 3 oxide that you had there. States how the main source of heat is provided in the blast furnace. Remember that the introduction of coke, so when you burn coke, coke supplies heat, the burning of coke, or you can say burning of carbon, that would be correct. So this is what supplies heat to the system. So one of the functions of the coke in the blast furnace is to supply heat to the process. Now, name the gaseous reducing agents in the blast furnace. Now, in the equation for the blast furnace, remember that we have first that the carbon reacts with oxygen to give carbon dioxide, that's the coke. Then the carbon dioxide reacts with excess of the coke to give carbon monoxide. And the carbon monoxide now reacts with the ore, that's the hematite, where you now form your iron plus carbon dioxide. So this is the reducing agent in the blast furnace. So the reducing agent here is carbon monoxide. So carbon monoxide, the reducing agent. And we all know why it's a reducing agent. You can see what has happened to iron. Iron moved from +3 here to 0, right? In terms of oxidation number, that shows that it has been reduced, right? And it has been reduced by this compound there, carbon monoxide. All right, now the next one says write a symbol equation for the reduction. Okay, we already have this here. So what we just need to do is to balance it up. And how do we balance it? We're going to have a 3-year, you're going to have a 2-year, and you're going to have a 3-year as well. So we just fill that in now. So it's going to look like Fe2O3, right, plus 3CO, and that gives you 2Fe plus 3CO2. That is the balanced equation for the reduction of the iron 3 oxide by carbon monoxide. All right, moving forward, next one says the main impurity in iron ore is silicon 4 oxide. Right, 2 symbol equations to show the role of limestone in removing removing silicon 4 oxide from the iron ore. Obviously, remember that first there is a thermal decomposition of the limestone, give calcium oxide plus carbon dioxide. So this is the first equation. So the first equation is termed thermal decomposition of limestone that you introduce into the process. Then the calcium oxide produced in this step then reacts with the solid impurity of the process, okay, which is silicon 4 oxide, and gives you the calcium silicate, which is also referred to as slag. So we just have CaO plus SiO2 CaSiO3. So the CaSiO3 is referred to as slag, or you simply call it calcium silicate, which is the solid, what is left over in the process. That is that for the extraction process. Right, let's move to the next one. So the next one takes us to isotopes. We have a question here, saying why A, B, C, and D are isotopes of iron. Now, from your knowledge of isotopes, let me see this a quick slide here that talks about isotopes. All right, so we have something here. So isotopes are atoms of the same elements that have the same proton number, but different number of neutrons, basically. So they have the same number of protons, but different number of neutrons. For example, we have chlorine 1717, or you can see 35, 37. That's difference in nucleon number because the number of neutrons are different. We also have carbon 6 exhibiting isotopy where it has 12 and 13. All right, so that gives us an idea of what the answer should be in the question we're looking at. So when you're defining isotopes, you have to be very careful. So our answer here is just, you could see mark allocation is for 2 marks. So you have to say that there are isotopes of iron. So they are atoms. They are atoms of the same element. This point is very important. Don't just say that there are atoms, but they are atoms of the same element. The word same here tells you that it is the same proton number, but okay, but different number of neutrons. So they are atoms of the same element that have the same number of protons, that have the same number of protons, but different number of neutrons. Okay, but different number of neutrons. So this is how you define isotopes. You check the question, you see that they are all iron, they have the same symbol. However, their nucleon numbers are different. So we go to the next one here. It says ion can form two different ions, ion 2 and ion 3. Okay, and then you have to complete the table. So this is quite easy as well. So you know what the proton number is. You have to check the periodic table for ion. So by the time we scroll all the way to where we have the periodic table, we look for ion right here. You see ion is here. So this is the proton number of ion, 26. So we just come all the way down there. That's how to make use of the periodic table. You always be given that in the exams. So the proton number of ion is 26. Number of protons is 26 in both cases. All right, since both of them are ion. All right, so let's go to neutrons. So to get neutrons is the mass number, or you could say the mass number minus the proton number. So the mass number in this case is 54, right? So 54 minus 26, 54 minus 26, that gives you 28 here. Then we'll do 58 minus 26, that gives you 32 here. So that's how to get the number of neutrons. Just do the mass number minus the number of protons, or the nucleon number, which is always at the top. Now for electrons, we have to be careful. The 2 plus here for ion simply means it has given out 2 electrons. Okay, so for us to get the number of electrons, since it has minus 2, and that will give you 24, and the other one is going to be 26 minus 3, since it's 3 plus, that will give you 23. So if it were negative, then you just add to the number of electrons. So since it is positive, it has given out electrons. If it were negative, it has received electrons. So that is the answer to that. Next one says, describe a test for aqueous ion 2 ions. So, of course, this involves your knowledge of alternative to practical, where you have to understand the experimental techniques. We have a slide here that talks about that experimental techniques. So you can see the test. So either you're using aqueous ammonia, or you're using aqueous sodium hydroxide. So these are the reagents. Either of them can be used for this test. And you can see the ion 2, you can see the results. It either gives you a green precipitate that is insoluble in excess, or a green precipitate insoluble in excess in both cases. So both of them give the same result. So we'll just have to name the test here. So the name of the test is adding aqueous sodium hydroxide. So I could use this as my own test. So yours could be adding aqueous ammonia. And then results, observations will be green precipitate, observe. Okay, and it is insoluble. It is insoluble in excess. So in drops gives you green precipitate, and then when you keep on adding, it's insoluble. Or you can also add the other parts that says it eventually turns brown after standing for a while. All of these are quite okay to get the mark. All right, so that is for this particular question. So we go to the next one.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Tech do have a private tuition. So by my right, you can see that we have for the Edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about and the fee is really quite affordable. It's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable and you get the very best of service. We also have for the E levels as well, um, and also for the edXL. So we have for the Cambridge E levels and edXL E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time, even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at Ajiro at gmail.com and they will reply to you.
We have that an oxidizing agent converts iron 2 ions to iron 3 ions. So define the term oxidizing agent. And you can see it's just for 2 marks. When you're defining an oxidizing agent, let's see, we have a slide here that talks about that. So you can see here that an oxidizing agent is a substance that oxidizes another substance during a redox reaction and is itself reduced during the reaction. These are the 2 points you have to make when you are defining an oxidizing agent. So in this case, we'll define it that same way. So it is a substance, it is a substance that oxidizes another substance, that oxidizes another substance and is in itself, so and is itself reduced. So if you want to determine if a substance is an oxidizing agent, then check if it is reduced in the reaction. And how do you know it is reduced in the reaction? You'd see a drop in the oxidation number. Next question says, explain why the conversion of iron 2 ions to iron 3 ions is described as oxidation. Of course, you know what oxidation is. Oxidation is loss of an electron. So in the case of iron 2 to iron 3, there has been a loss of electrons. So there is a loss of an electron in this case, the loss of an electron. That is why it is referred to as oxidation. Now, the oxidizing agent for the conversion of iron 2 to iron 3 is aqueous potassium manganate 7. It's one condition needed for the oxidation to take place. For you, one condition to be able to use this aqueous potassium manganate is that it should be acidified. So it should be acidified. So that is condition. Either ions reduce iron 3 ions to iron 2 ions in aqueous solution. So just the identity of the other product formed in this reaction. So if this reduces this, therefore, this is going to have the iodine. So you're going to have the iodine as the last product there. So you're going to have the I2 formed, okay, because it has reduced this. So meaning if it has reduced iron 3, that means this has been oxidized. And for iodine to be oxidized, it's moving from -1 to the stable configuration or stable state, which is 0. This is why it's iodine right here. Okay, we move to the next one. The student prepares a sample of the insoluble salt barium sulfate. The student adds aqueous sodium sulfate to aqueous barium chloride. Okay, so remember when you're preparing insoluble salt, you need 2 soluble salts. Prepare an insoluble salt. That's precipitation. All right, so the student carries out the following steps. So dissolves, all of this information are there. So let's start with the answering of the questions. So the first question says we have to complete the simple equation and balance it, of course. So look at this. You have barium chloride plus sodium sulfate. You have barium sulfate. So that means the barium is taken off. The sulfate has reacted, so we are left with sodium and chlorine, and that would form sodium chloride. All right, since you're producing an insoluble salt, this needs to be solid because that is the insoluble salt, obviously, and then the sodium chloride will be in the aqueous form. And then we need to balance this, right? So there are two chlorines there, so we just put it two right here. Okay, so that solves that question. I'll go to the next one. It says calculate the mass of barium chloride dissolved in step one. So let's read step one. In step one, we have the number of moles of barium chloride in 100 centimeter cube of water. So remember that the formula says number of moles is the mass over the MR of barium chloride. Now we need the mass. So the mass is the number of moles times the MR. We have the number of moles given in the question, but we need to get the MR of barium chloride. So MR of barium chloride. So barium, check the periodic table. Barium should give us so the barium chloride should give us, so let's check barium right here. So you can see barium is 137. So barium is 137. So we just have 137 plus chlorine 2 times 35.5. So if we sum this up, so let me use my calculator. So it's going to be 137 plus 71. Okay, so I'm having 208. So that's the MR. So if the MR is 208, then the mass would be 0.1 times 208. And that should give us 20.8. So this is the mass of barium chloride based on the instruction we have in step one. Now, the next one is the concentration of sodium sulfate in step two. This is the concentration to be 1.25 mole per dm cube. Now, calculate the volume in cm cube of 1.25 mole per dm cube of the sodium sulfate in step two, which contains 0.100 moles of sodium sulfate. So we want the volume, and remember, there's a relationship between concentration and volume, right? And that relationship is concentration is equal to the number of moles divided by the volume. However, we need the volume, so volume would be number of moles over concentration. All right, so that would lead us to the answer. So do we have the number of moles? Yes. Since we are asked to calculate the volume in cm cube of sodium sulfate, number of moles of sodium sulfate is already given to be 0.100. 0.100. However, we could V equals to number of moles is 0.100 divided by the concentration is 1.25. All right, so let's divide this and let's see what we have. So I'm going to use the calculator again. So it's going to be 0.100 divided by 1.25. So I have V to be 0.08 dm cube. But the question wants it in cm cube. Remember, so we have to convert now. 1000 cm cube is equivalent to 1 dm cube. Therefore, for us to have 0.08, so it's going to be V will now be 0.08 times 1000. All right, and that should give us the final answer, which the calculator here is going to give us 80 centimeter cube. All right, and that's how to solve that particular question. Okay, moving forward. Now, we says
In today's world, science isn't just about passing exams. It's about understanding how the world truly works. At Ajiro Tech Tutoring, we help students master the sciences, physics, chemistry, and biology across all major exam boards, AQA, EdExcel, and Cambridge International. With our team of qualified tutors, every session is designed around you, your pace, your goals, your success. We don't just teach, we build confidence, critical thinking, and curiosity. And now, we're proud to say we are officially registered right here in England, in the UK, delivering trusted, high quality online tutoring that meets British educational standard. Whether you're preparing for GCSE, IGCSE, or A levels, Agile Tech gives you the tools to achieve your best result from the comfort of your home. Because with the right guidance, science becomes simple, success becomes natural, and learning becomes limitless. Begin your journey today at agiletech.com or message our sales team info@agiletech.com or agiletech@gmail.com. Agile Tech Tutoring, where understanding leads to excellence.
The same information now, it says state the color of the solid formed in step 2. So what was done in step 2 was take your solution, which contains 0.10 moles of sodium sulfate, was added to barium chloride. Okay, so the color of the solid form, barium sulfate, you should know that from your knowledge of experimental design, that the color is white. Okay, barium sulfate has the white color. The mixture is filtered in step 3. State the general term given to a solid left in the filter paper after filtration. Now remember that when you perform filtration, the solid left is the residue, while the liquid in the containing vessel or the conical flask is the filtrate. So the solid part is the residue, the liquid part is the filtrate. That solves that quite easy. All right, so we have this here now, still the same information, but now it says the actual mass of dry barium sulfate collected in step 4 is greater than the expected mass. This is because the students should do an additional step that was skipped. Okay, so suggest what the students should do in this additional step and explain why the actual mass collected is greater than the expected mass. So after stirring the mixture and then filter it, the student is expected to do something before drying, and that is called rinsing the residue with water. So rinsing the residue, rinsing the residue with water. That's the missing step. That's the step that should have been done before drying. Now, why the actual mass is greater than the expected mass? Simply because the dry residue, the dry residue contains solid sodium chloride. There is still some traces of sodium chloride in the dry residue. That is why the mass is higher than expected. Okay, so that means that the process still has the impurities of uh, solid sodium chloride. Right? So state the name of this method of salt preparation. So, like we already said, you're trying to prepare insoluble salt, so it's called precipitation. That's the name of the step. All right. Now, state the name of a different barium salt that can be used in place of barium chloride. Now, remember that we are dealing with producing an insoluble salt, and to produce insoluble salt, you need two soluble salts. And I have a simple way to learn your soluble salt. We have SNAP. SNAP to snap sodium, S for sodium, N for nitrates, A for ammonium, and P for potassium. So snap, just like it's snapping a picture. All right, so if you want to pick barium, barium is already a cation. So that means if you want to pick a soluble salt, you have to pick an anion here, which is nitrate. So if I don't want to use barium chloride, I, I could use barium nitrate instead because all nitrate salts are soluble. So that would be my answer here, barium nitrate. Remember, this SNAP is for all soluble salts. So this is a list of all soluble salts. So any of them, any salts that contains any of this cation or anion is soluble. Sulfate salts that can be used in place of sodium sulfate. So sulfate is an anion. So I can pick any of these cations that are here. So any of them, it could be sodium sulfate, it could be potassium sulfate, it could be ammonium sulfate. Any of them fit in here because they are soluble. So I'll just pick a simple one there, potassium sulfate. Let's go towards the carbonate end. So you can pick barium carbonate. You can produce barium carbonate using this method because barium carbonate is equally insoluble. Okay, barium carbonate is equally insoluble. So we can use that method to obtain barium carbonate. All right, so that moves us away to the next question. Nitric acid and sulfuric acid are strong acids. Okay, states the formula of the common cation produced when each of these three acids dissociates. So of course, you remember that acids are defined as proton donors. Acids are proton donors. So what it means is the cation being pulled up here is the hydrogen. Now, explain in terms of dissociation why nitric acid is described as a strong acid. Now, strong acids are acids that completely dissociate. So why we refer to nitric acid as a strong acid is that completely dissociates. Right? And then the ethanoic acid is described as a weak acid because it partially dissociates. So that's what differentiates them. Now, apart from the fact that it's just by words, for example, if I want to dissociate nitric acid, it's going to look like this. I'm going to have a single arrow. So this is nitric, this is strong acid dissociation. However, if I want to dissociate ethanoic acid, it's going to be a reversible arrow because you were talking about partial dissociation. You're going to have CH3CO minus. So if I'm writing an equation and you do not include this reversible arrow for the weak acid dissociation, you lose some marks. So that is what differentiates a strong acid dissociation from a weak acid. Get which of the three dilute acids will have the highest pH value. Of course, it's going to be the ethanoic acid, okay? Because the lower pH means it is very acidic. So ethanoic acid would have the highest pH value. Take the call of time of phthalate in all three dilute acids. So remember your indicator, time of phthalate is colorless in an acidic and a neutral medium. Give the formula of the anion formed when sulfuric acid dissociates. If I want to dissociate sulfuric acid, the strong acid, so it's going to be 2H plus SO4 2 minus. So the name, the formula is the sulfate ion, so I just have SO4 2 minus. And then for ethanoic acid, I've shown that here, the anion is a -1, so it's this is it here. So that is how to get an answer to that. So it's quite easy as expected. Okay, we've done this, so this is more like a repetition. Now the next question says, name the two gaseous products formed during the electrolysis of dilute sulfuric acid using inert electrodes. So we have sulfuric acid dilute, so we're going to have ions there are going to be H plus. For the sulfuric acid part, you're going to have SO4 2 minus. And for the aqueous part, you're going to have H plus again, and you're going to have hydroxyl ion. All right. So these are the two categories that are going on here. So of course, you're looking at this cathode, then anode, that the ions competing. So for this, both of them are already there. So there's really nothing here to compete, just hydrogen. And remember, cathode, there's gaining of electrons. The H plus gains an electron. Then you have your hydrogen, the atomic hydrogen here, and then you have your two here. Right? So the product at the cathode, this is an inert electrode. So we have hydrogen as one of the products. Hydrogen. All right, so let's go to the next one. For sulfate and hydroxide, remember the rule is the less reactive one is deposited. So in this case, the hydroxide is less reactive, so it's deposited. And whenever hydroxide is deposited, we're going to have oxygen gas, we're going to have water, we're going to have the electron deposited. So we're going to have 4 here, 2 here, and 4 here. So the gas, we're going to have bubbles of oxygen gas produced. Right here, we'll have oxygen. Name the salt form when calcium reacts with ethanoic acid. So remember from the organic chemistry, when the organic acids react with calcium, you're going to have calcium, have the metal base, calcium ethanoate. Okay, so that's straightforward enough. And then the next one, define the term base. Of course, you know, base is proton acceptor. We already defined an acid to be a proton donor. So a base is a proton acceptor. This is the definition the syllabus expects you to always give for base and acid. Please always remember that. A base is a proton acceptor. Now, AlOH3 is not an alkali. States what this tells you about the solubility. So remember that since it is not an alkali, means it is insoluble, right? Because alkalis are bases that are soluble. When you have a base that is not an alkali, therefore it's an insoluble base. Name another compound which forms aluminum nitrate when added to dilute nitric acid. Okay, so of course, pick another compound apart from aluminum hydroxide. That could be aluminum oxide. Aluminum oxide could do that as well because of its amphoteric nature. Remember, amphoteric simply means it can react with an acid or a base. So since the aluminum hydroxide is acting as a base, aluminum oxide can also act as a base so that when it reacts with the acid, it forms the salt. The oxidation number of oxygen atoms in this is -2. The formula of the aluminum nitrate rather is -2. The formula of the aluminum ion is this. Determine the oxidation number of nitrogen. So let's solve. We already told that aluminum is +3. So we start from here. This is our compound. So we just fix them in. So +3, that's aluminum plus. Now there's a 3 outside and there is an N. So 3N, that's the unknown, plus 3 times 3, 9. Oxygen is -2, so 9 is the bracket -2. Since it's a neutral compound, we have a 0. Equal to 0. So we have +3 plus 3N minus 18 equals to 0. So 3N will be equal to 18 plus 0 minus 3. 3N will be equal to 15. And then your N will be +5. That's the answer to this. Quite straightforward. Okay, we'll go to the organic chemistry part now.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Tech do have a private tuition. So by my right, you can see that we have for the Edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable and you get the very best of service. We also have for the E levels as well, um, and also for the edXL. So we have for the Cambridge E levels and edXL E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time, even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at Ajiro at gmail.com and they'll reply to you.
We have three general characteristics of alkanes given, right? It says describe two other general characteristics of the homologous phase of alkanes. We already told that they are unreactive, and you already told that they show trends in their physical properties such as melting point and boiling point. They have similar chemical properties. So describe two other general characteristics. So you could say they have same general formula. They have a general formula the general formula is CnH2n plus 2. And then the second one could simply be that each successive member differ, each successive member differ by a CH2 unit. Or you could say successive member differ by a mass of 14. Either of them is correct. So each successive member differ by CH2 units. Now, state the trend in the boiling point of the alkanes as the carbon chain length increases. Of course, as the carbon chain length increases, obviously the boiling point increases because the intermolecular force of attraction becomes stronger. Name one other physical property of alkane that shows a trend other than melting point and boiling point. Describe this trend as the carbon chain length of alkane increases. So we can say the physical property. So physical property in terms of, we could add the density. Okay, so we can name it as the density. See, it's what increases as chain length increases. Okay, so that solves that particular part of the question. All right, let's go. State why alkanes are described as saturated. Now, remember that we refer to them as saturated because they have all carbon-carbon single bonds. They have carbon, carbon, single bonds. That's what makes them single bonds. They have all carbon, carbon single bonds. They have carbon, carbon single bonds in their structure, all of them. Now, propane has the structural formula this. When propane undergoes monosubstitution with chlorine, two organic products can be formed. One condition for this is obviously need ultraviolet light. Ultraviolet light is needed. So it makes it a photochemical reaction. Give the structural formula and state the name of each organic product formed. So the structural formula is, so we're going to do a quick explanation of how this would look like. So remember that this is the split formula first. So we have three carbons, then we have hydrogens all the way here. Okay, so we are introducing chlorine. Okay, so plus Cl, Cl. So what happens is that chlorine just attacks one of the hydrogens. Okay, it occupies like a substitution. It takes the position of one of the hydrogens. So the structural formula of the first one of the first one would look like this. So structural will look like CH3, CH2, CH2Cl. Okay, because we are just assuming it occupies this position. You could occupy any of these, which is the same thing, since it's on the same carbon. All right, so that name of that one product would be so 1-chloro. Okay, so the other product could simply be a structural isomer. All right, so it could just be it's moving instead of going to position 1, it could move to position 2. So we could have CH3, CHCl, and CH3. So this will now become 2-chloropropane. So 1-chloropropane and 2-chloropropane are simply structural isomers of themselves. All right, I think we go to the next one. The two products formed are structural isomers of each other. Okay, of course, we already said that. So it says, what does it mean? What does the word structural isomers mean? So they are compounds with the same molecular formula, but different structural formula. So that is the definition of isomers. So if you count the numbers of carbons, hydrogens in structure 1, and you count the number of carbons, hydrogens, and chlorine in structure 2, they are the same. That's what we mean by the same molecular formula. They have the same actual number of atoms. However, how they are drawn are different, and that's what makes this different structural formula content. Okay, so moving forward, it says on figure 6.1, draw a circle around all atoms which make up the ester linkage. So when we talk about the ester linkage, it's just this. This is the ester linkage. Okay. Now we have to name compound E. Now, when naming compound E, you would name the right-hand side first. So there are 2 carbons, that's ethyl. Then you name the left-hand side, propan first. So that's ethyl. And then you name the left-hand side. So the left-hand side has 4 carbons. So 1, 2, 3, 4, and that's butanoate. Okay, so I think it should be the last slide we have here. Deduce the empirical formula of compound E. Now, for us to deduce the empirical formula, it's in count. We're going to count all of the carbons, hydrogens, and oxygens that are here. So let's count carbons 1, 2, 3, 4, 5, 6. There are 6 carbons. Hydrogen 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 3, 12. 12 hydrogens. And then oxygens, we have 2 oxygens. So empirical formula is the simplest ratio of the atoms. So let's simplify this completely. If you simplify this, you divide by 2. So divide by 2 because that's the simplest form you can have. That will be C3H6O. So that is the empirical formula. This is the molecular. So the simplest form of it is this. Compound E is produced when 2 different compounds react together in the presence of a catalyst. Name the 2 compounds that react together to produce compound E. Now, I said the right-hand side is the contribution of the alcohol, while the left-hand side is the contribution of the carboxylic acid. So an alcohol with 2 carbons is referred to as ethanol. A carboxylic acid with 4 carbons is referred to as butanoic acid. That is how to go about that. The suitable catalyst for this reaction is acid. So we need acid for esterification, say concentrated sulfuric acid. Okay, or you can just say an acid. Determine the number of unbranched esters which have the molecular formula C5H10O2. All right, so for an ester with a C5 H10 O2. So what combinations can we have for such esters? We can have 2, 3, because it's 5 carbons. So you based it on the 5 carbon combination. So 2, 3, you can have 3, 2, you could have 4, 1, and you could have 1, 4. So these are the combinations that can give you 5. 2, 3, 3, 2, 4, 1, 1, 4. These are the esters that you could form. So this could be the esters. So there are 4. So the answer becomes 4. And on branch ester with the molecular formula C5H10O2 combust completely to form carbon dioxide. So we have to write the equation. So C5H10O2 plus CO2, sorry, plus O2 rather. C5H10O2 plus O2 gives CO2 plus H2O. So let's balance. We are aiming for 10, so we could just put it 2 here. So there are 10 carbons here, and then there are 20 hydrogens. We have to put 10 here, right? And then for oxygen, let's calculate for oxygen. Oxygen is 2 times 2 here, 4. Oxygen on the right rather is 20 plus 10, that's 30. So there is already 4 here, so we need a 13 here, so that it becomes 26 plus 4, and that gives us 30 oxygens. So this brings us to the end of this paper. I hope you were able to learn a lot of things and the way we were able to give answers to questions. Like we already said earlier, for private tutoring, for resources, just message the sales team and we'll give more reports on that. Thank you for watching, and keep on subscribing and sharing with your friends.